Hello everyone. Today we are here to discuss a fascinating application of data science that is forecasting the monthly beer production in Australia. Beer production in Australia is a dynamic industry influenced by a multitude of factors from seasonal consumer demands to economic trends. For breweries, accurate productions are not just a luxury but a critical necessity. They enable efficient inventory management, optimized resource allocation, and informed strategic decision making, ultimately impacting the profitability and the market competitiveness. Overproduction can lead to costly wastage and storage, while underproduction can result in missed sales opportunity and dissatisfied customers. This presentation will dwell into how we can leverage the power of time series analysis to predict the future beer production volumes. Looking at the data consists of monthly production from the year 1956 to year 1995. We can observe there is an increasing trend, and this could be due to popularity and demand. There is seasonality in the series as well as change in variance from the year 1970. There are no such change point that is observed, and the plot shows moving average behavior. The dataset was sourced from Kaggle and the source link is provided below. Based on the ACF and PACF plot, the ACF plot shows a depreciating pattern suggesting there is seasonality in the series, while both ADF and PP test gives a p-value of 0.01. Though it is below the critical value, it is still considered a borderline value and cannot be fully trusted. Before moving to the model specification, the series was transformed using Box-Cox method with a lambda value of minus 0.3 to reduce the effect of change in variance. A first-order seasonal differencing was implemented to reduce the seasonal effect, and the seasonal P and seasonal Q were found out to be 3 and 1. Further, to make series stationary, ordinary differencing was performed and ordinary P and Q values were determined, that is 9 and 7. Using ESCF plot, the top left row was considered to be in order 3 cross 4 and the 4 models were determined, that is the Sarima 314, 414, 315 and 415. Similarly, using BIC plot, two models were determined with a p-value of 3 and 7 with a q-value of 1. After doing all the residual analysis and coefficient tests from all the possible models, model 415 showed a more confidence. But looking further, we performed AIC tables and BIC table scores to check which could be the best fit model. And based on the AIC, the model 415 turned out to be the best one, and with the help of BIC, the model 314 was turned out to the best one. But looking at the difference in the between model 415 and 314 in the BIC model, there is negligible difference. But for after fitting a linear model and looking at the post-processing parameters such as MAC, MAP, RMAC, and MAE, we can clearly say that the 415 stand out to be the best, having the lowest MAC value, lowest MAP value, and there was hardly any change in MAE and RMAC value among the models. A residual analysis on the finally decided model, that is the Sarima 415, we can observe that the residuals were in the standardized residuals were in the range of -2 and 2, except one point that was reaching up to -4, and this could cause the skewness in the data and causing the residuals to be not normally distributed. Similarly, that was observed in the case of histogram, where the most of the data was in the range of -2 and 2, with a skewness due to one point caused to the side of -4. The QQ plot shows the data is normally the residuals are normally distributed, but that was denied by Shapiro-Wilk test, and that is due to the reasons of having some outliers that is causing the skewness. Similarly, in the ACF of the standardized residuals, most of the points were below the threshold except one point, the outlier, that was showing a correlation of the lag. Based on considering all the factors, model Sarima 415 was considered as the best fit model. The overfitting didn't provide with any new models for this use case, while the coefficients were below the thresholds of p-value. The models also is backed by BIC, AIC, and post-processing parameters such as MACE and MAP. The model will be used for further forecasting of the monthly beer production in Australia. Thank you, everyone.